recording this, and I will share my screen. So I just want to start by remembering what the formula is for integration by parts, okay? So remember that the whole point of all of our tools, and we still have tools to come, is that we want to simplify the integral and make it something that we can solve by inspection, okay? So our new tool is integration by parts, which says we're taking the integral of u dv, which usually means we have two things multiplied by each other. We'll talk about how this might be a little different later. And then that ends up being uv minus the integral of v du. And remember that this comes from the product rule. Okay, so u substitution is kind of undoing the chain rule. Integration by parts is undoing the product rule. Okay. And then you were supposed to have an answer for me, I believe. It's not really number 25. I take that back. It's number 25 minus. But we had the integral x secant squared x dx, and you're supposed to finish that. So if you didn't finish it, take a minute and finish it. And then somebody can share their answer. I believe we were to the point where we had x tan x minus the integral of tan x dx. Is that true? That's where we were. We're supposed to evaluate that other integral. That reminded me that I had been carrying this around for 11 months so that I would have it. All right, so we got an answer. Is anybody completely stuck? It's okay to say you got no idea what to do. Any brave soul? Okay, so you come to an integral. Can you solve it by inspection? Not really. What's our next line of defense? U substitution, right? And this is great review. Where do we look for U's? The denominator. So I'm going to call this, just because I think it makes life a little simpler, I'm going to call this a W substitution because I've already used X. Okay? So if I let W be cosine, then what would dW be? Negative sine dx, which happens to be exactly what I have. So this is, oops. So this is going to become x tan x minus, or actually plus, the integral of 1 over w dw, right? So that gives me x tan x plus, and what's the antiderivative of 1 over w? Natural log of w plus c, and then I substitute it. So I have x tan x plus the natural log of cosine x, got to have our absolute value signs in there, plus. Okay, we good? All right, so I feel it's really important that you just keep practicing. Okay, so I would like you to do one. It's not in your notes because I was just thinking about it yesterday. So you solve this. So it's the integral of x e to the 5x dx. Okay, how we doing? Did I do it right? Questions? Okay. Well, so you see where I got my 1/5 originally, okay? But then when I integrate this, the antiderivative of that is still 1/5 e to the 5x. So now I've got 1/5 times 1/5 e to the 5x. Amy, Yvette, you doing all right? Yes, okay. Okay, so there's more practice to do. There are more wacky situations to see. So we're going to go back to your notes, and we're going to go through an example where you actually have to use integration by parts twice. Okay. So I think if we go back to your notes, the next thing is x squared cosine x over 2 dx. Yes? Okay. So once again, we've come to an integral. Can we solve it by inspection? No, way too hard. Okay. But, and can we use u substitution? No, that's really just going to end up giving you u squared times cosine of some kind. Okay. So what does that leave me with? Integration by parts. So again, you might want to remind yourself of the formula. It's the integral of u dv is going to be uv minus the integral of u du. You really do have to memorize that. So I don't know, you know what I think. The more you write it down, the better chance you're going to have of remembering. Okay. So then we need to pick our u and our dv. And then what's the problem going to be? So remember that the whole point of this is to make my integrals simpler. Okay, make it something that I can integrate. So if I let cosine x over 2 be u, what am I going to get? Okay, so I'm going to get sine x times something. I think Fiona got it right. Okay, and that's the whole problem with the trig function is I'm always going to get another trig function. Okay, whether I'm integrating or taking the derivative, it's just, especially sine and cosine, I'm just going to alternate back and forth. Okay, but what's going to happen if I let u be x squared? What am I going to get for du? I'm going to get x dx, okay, or 2x dx. All right, so that would at least make it one step simpler, and then we'll see what happens. So we'll let u be equal to x squared, and we'll let dv be cosine x over 2 dx. In general, polynomials are a good choice for you. Not always going to work, and it doesn't work when you have to remember that you need to be able to integrate whatever you let be equal to dv. So for instance, you really can't integrate easily natural log. Okay, so you can't let dv be equal to natural log x. So what's du going to be? 2x dx, like we talked about. And then what's v going to be? A little harder. You might have to go off to the side and do a w substitution. So Fiona says 2 sine x over 2. I need somebody to tell me she's right. Yeah. Kim verifies, and I agree. I said add dx. Oh no, you don't have to. It's okay. I do that. I've done that a handful of times myself. Okay, so that means that our integral becomes u times v. So that's 2x squared sine x over 2 minus the integral of v du. So that's going to give me 2x. Actually, hang on. It's going to be the integral. That's going to be 2 sine x over 2 times 2x dx. So I'm just going to clean up my 2's over here and bring them outside the integral. Okay? So again, we've come to an integral. Can I solve it by inspection? No. Can I use a U substitution? No. So what do I have left? Integration by parts. So again, I've got to pick a U, and I have to pick a D. So what should my U be? X, right? Because then du will just be what? Dx. Okay. How about, so that leaves for dv sine x over 2 dx. And I will call on someone to tell me what it is. Kim, what do you got? Kim, right? Fiona agrees with you. Still see a couple frowny faces. How'd she do, Amy? Is that right? Amy agrees with you. Okay. So I am asking you to do a U substitution, or what we're going to call for right now a W substitution on your own. But you don't have to do it in your head. You can just go up to the side and do it if you still don't feel comfortable with figuring it out. Okay. All right. So we don't want to forget our 2x squared sine x over 2 that's hanging out of here. This is going to be -4, but remember, I'm taking this whole integral here, and I'm applying the integration by parts. So that's going to be times -2x cosine x over 2, that's times b, minus the integral of b, -2 cosine x over 2, du, which is dx. Right, and now we're going to do some algebra. So I've got 2x squared sine x over 2, nothing happens there. Got to do some multiplying here, so that's going to be positive 8x cosine x over 2 minus 8 integral cosine x over 2 dx. Are you with me? All right, so I'm just going to copy this line down again until I get to my integral. And then what do I get? What's the antiderivative of cosine x over 2? 2 sine x over 2. Don't forget our plus c. Okay, and then we're just going to distribute things here again. So I've got 2x squared sine x over 2 plus 8x cosine x over 2 minus 16 sine x over 2 plus C. What do you mean? Do you want to see things above it? No, I don't think so. No. No, I'm pretty sure of it. Because where would the other negative sign come from? Oh, you gotta be, it gets whacked with the derivatives and the antiderivatives. But if I take the derivative of this, it's positive. So that negative sign stays. But it gets whacked. Totally understand. Okay, good? And you know I count okay, we all right? Okay, so let's try another one. So our next one allows us to review taking the derivative or the integral of a to the x. All right, so our example is the integral of 3 to the x cosine x dx. And actually, I want to go back to the other example for 1 minute. Okay. What was the power of my polynomial here? What was it? 2. And how many times did I have to do integration by parts? 2. Okay. Because what I was doing is every time I did integration by parts, I lowered the order of that polynomial by 1 until it disappeared. Okay, so that's just something to help you pace yourself. Okay, so that you know that doing integration by parts once isn't necessarily going to be enough. Okay. All right, so you've come to an integral. Do you know how to solve that by inspection? Use substitution going to help you? No, because it's pretty much just going to be 3 to the u cosine u du, and that's just rewriting it with a different variable. So it's the only other tool you have in your tool chest right now. Integration by parts. So again, we have the integral of u dv is equal to uv minus the integral of u dv. So this is going to be interesting. Okay. So that means I have to pick a u, and I have to pick a dv. So what am I going to pick? Dag. Okay, so I'm going to make my u 3 to the x. That means my dv is cosine x dx. Let's do the v first because it's easier. So it's the antiderivative of cosine x dx. Sine x. Okay. So then I have to find v. How do I take the derivative of that? Please don't tell me it's x times 3 to the x minus 1 because it's not. So you might have to do a little research, go back and see if you can figure out how to do that. Dagny, did you remember? Okay, see, what you have like a little card that's got x full length because this is one you got to know. So what is it, Dagny? So 3x times the natural log of whatever that constant is. A formula worth having around. All right. We talked about getting like a little index card that fits inside your calculator. and writing down the important formulas like integration by parts like this, that would be a good thing to do. Okay. I'm pretty sure that you've got like the derivatives of sines and cosines, like, because you just know that by now. But like those inverse trig functions, those are hard. Okay. All right. So this gives us then u times v minus the integral of u times u. Oh, there should be. Okay, so you've come to an integral. What are you going to do? And I'm just going to like clean this up a little bit. I'm going to bring that natural log to that side, just so that it doesn't clutter and get in the way. So, come to an integral. Right? 3 to the x is never going to go away. Whatever that trig function is never going to go away. And yet you can still solve this. So, again, let's just play along for the mo. I've come to an integral. What do I do when I come to an integral? I solve it by inspection? Heck no. Integration or substitution, still not going to be a problem. So that means I need to use integration by parts. So that means I need u and v. Omniscient narrator. If you want this to work out, you want to keep your choice of u and dv the same. Okay, so if I chose 3 to the x as my dv4, I want to choose 3 to the x to be my v now. And then my dv is going to be sine x dx. Dead.
Is that how that we follow like every time we have to?
Yes. Because what's happening is you've got two functions that are never going to simplify, and you'll see what happens. Okay? So that means that my du is going to be, again, natural log of 3 to the x dx. And what's my v going to be? Negative cosine x. Okay. So my original integral was 3 to the x cosine x dx. Okay. I have my original uv, which was 3 to the x sine x, minus the natural log of 3. And now I'm going to fill in this integral, okay, using integration by parts. So that's going to be uv minus the integral of v du. that up so people can see. All right. So I'm going to start by distributing this negative natural log 3. Okay. So I still have the integral 3 to the x, cosine x dx, 3 to the x sine x, plus natural log 3, 3 to the x cosine x, minus natural log 3 squared integral 3 to the x cosine x dx. Which of course you can't see, but you try to, you can do this algebra on your own, I promise. Okay. So, like Kim said, this just repeats. And I'm back to the same integral that I started. But what I can do is solve for that integral as if it were a variable. If it makes you happy, I can call it W. So that you can see. So this would be W would be equal to 3 to the x sine x plus natural log 3, 3 to the x cosine x minus the natural log of 3 squared W. Right? And then I can solve for that. Right? So I'm just going to bring it over to the other side, and I've got W times 1 plus the natural log of 3 squared, 3 to the x sine x, plus the natural log of 3 to the x cosine x. Divide both sides by what's hanging out there. Yes, dear.
What happened to the other W?
I brought it over the other side and factored it out when I was over here.
Okay.
So then I remember, oh, and I forgot that I got to put a big old plus C there. Okay, so my W is 3 to the x cosine x dx. That's going to be 3 to the x sine x plus the natural log of 3 to the x cosine x divided by 1 plus natural log of 3 squared plus. Okay. Okay. I'm done. This is it. Because what I needed to do was to solve that integral. Okay. All right. So I think if you go all the way down to the bottom of your notes, I think the last thing you have is the integral of e to the negative x sine x dx. Yes? You solve that. Sandy, do you do it here? Yes. You will. Did you understand how you did this one? Let's try the other ones. Betty, you can figure it out. So let me know. Okay, so what's going on? So you started with this one. Okay, you wrote it down. Now do it. Right, so but what you should see is that we can go back and go back the times all that W solve. Okay. So keep going. Do the next. Do the next integration by parts. Right? Fine. So I will take all of their answers. Yes, but it feels, don't forget about, remember that all of this is up here. So if you're solving this integral, but you've got this is equal to this plus what you have to do. Okay. So so you need to, so now you need to write equals. Well, what you, so like when I do it on the board, I have this is equal to this line. Okay. But then that's equal to, when you write this in your integral is what you found in here. So you're not keeping track of the equation. You're doing all those little pieces to determine that the pieces go into the equation. So just be cognizant of that, be conscientious about it. Good. So let's do, so you don't erase it. I was saying to Sophie, I would make sure that you bring this down right there. Step that. So that's going to be UV. But then this is UV. So that should be negative 2 sign. That's row. That's okay. Right, it is super normal. So this is wrong. I would take another line, okay, and multiply through those negative signs, and then do not use t, okay, and put them over. Okay. So like, what's the derivative of sine x? Right, and that's not with negative cosine, so that should be a negative in there. And that's probably the difference. Actually, Kim, I hope you're right. Now that I think about it, I'm gonna look again. I mean, this is what the answer is. Is that what you had? Very lost by a second. Close. You're just off by a factor of 2. Well, because you had one W over here and one W over here, right? So when you added your W's together, you should have got 2. This whole thing is equal to this, right? That and that, the W. This. Yeah. Yes. You're up by negatives. Yeah. So let's see. So, all right. So let's don't erase it. Pick a different color if you wish. Just so write the integral down to the original. Equal to. So we did your first dV, right? So it's equal to times v. Minus. And dV. So now you got up here where you did your again. So like, let's start with everything again. and then you do du. And I just need to be more careful about your negatives. Just to show you. How did it work out? And then, this. Okay, so let's see. So let's go over different colors. But I want to see everything. So start by writing the whole info. Equals. So you've got you did your first use of your integration by parts. So you've got UV. Okay. Now, hang on. What's the derivative of cosine? Right. So that needs to be negative cosine. So don't worry about fixing over there. Let's just keep going over. Erase that. You don't need that. But you're using integration by parts, so that's going to be equal to U times E. So that's U times E. So that minus equal, and now you're to here. Yes, so start all the way over here and write that again. Okay. So now we're going to do integration by parts, which it looks like we did down there. So again, write the whole line until you get to the integral. So now you do times. Oh, yeah. It's this. Oh, because so you've got 3 negative signs here, so that has to be negative. Minus really has to. Yes, no. Get it? So let's see what you got. So you made your choices. That all looks good. So you did that. Okay, so now you're making your second set of choices. So that's your U, that's your V. There's this red interval here. Or this red interval. It's like this. Yeah, cosine x dx. Okay. So then what's the antiderivative of that? So let's let's erase this line for a minute. Okay, just because for one thing we need some more space. So let's go down to here. Okay. You write that again, the interval, so that you have an idea of what you're coming back to solve for. Equals. So it's still this negative u to the negative x cosine x minus parentheses. Okay, so u times v, and you're putting u. minus your integral of u to v. So you might want to keep this up if you can. So now u to v. And then you're actually good from here. It's all algebra. So go through and be careful with your negative signs, and you should be able to solve for that. Okay? All right, anybody else need a little nudge in the right direction? So let's come down here and start again. So write your integral. Erase it. So that's equal to u times u, that you need your v versus u times v. So what's that? Minus now your integral. Combine all your negatives. So you got to write the integral on your side. Only out of this. So now, just well, now we know. Okay, I can use another good. So this is what we chose up here, right? And because you've got different negatives, that's what you just do again. Move on to the side. Just make that bigger. Oh, it's important. Right? Right, the integral. Minus parentheses u times v. Minus u. So it's also, and now you just need to distribute your negative signs and be careful about them. You should look at okay.
So I thought almost but another I don't know how that.
I don't know. So so it shows that. Well, part of it is one thing is that you're missing negative signs. Negative sign from the one, there's a negative sign from the that's the negative SDX. Oh, and there's a negative sign from the close. So you don't have enough negative signs. Yeah, so you need another negative sign. Or that's fine. Okay. So then if you go over here, okay, but you don't have that negative sign. So just make it right. So if you look here, you just have the x, the negative x.
Yeah, but
Okay. Yeah. Let's erase it. Okay. Usually for that way. So over here, what's u getting equal to? This one for that little for this integral is yep. That's 2. Is x. So b is negative sign. Oh, because we're already going to sign x is sign. Yep. Okay, so go back over there, write the integral. C's, an integral. It's not all, and it's v. Minus neither here. So now, just need to carefully get rid of all the negative signs. Right. Shoot. Did it work out in the end, Sophie? Okay, you're fine up to here. Okay. Well, okay, so you have 2 negative signs here, so that integral should be positive in this line, right? You've got a negative sign here and a negative sign here. So you understand that it's not positive. Yeah. Okay. Right? You understand there's a negative sign here and a negative sign here. So that should be plus. So now let's erase what's here. Erase all of it. All right. So now very carefully get rid of your, very carefully distribute that negative sign. Right? So like that. Where did this thing? Okay, so there's this negative sign. Why is it not? So now, this to the other side. Oh, W if you want. But this is a W too, so we write it W equals. Now solve for W. Okay. Amy, Yvette, did you get it? Yes? Okay. So I think I'm going to let you go because this is hard. We're going to spend one more day on this tomorrow because I think you need to practice. And there are some other things we need to look at, and especially there's kind of like one more big idea that goes with this that we need to look at. Annabelle. Okay.
Can I ask you a question?
Yes.
So, when you have a problem that you think like is gonna reduce, so you just have to solve it the way you solve the last two problems, you just have to go through it twice and then like do integration by parts twice and then solve.
So Annabelle's question is, if you have a problem like this where you think you're going to get your integral back, do you only have to do integration by parts twice? And I believe the answer is yes, because what's going to happen is whatever, it's usually something that's an exponent and something that's like a sine or a cosine. And so what's going to happen is by the time you do the second integration by parts, your sine has flipped to a cosine and it's flipped back to a sine, or it's gone from a cosine to a sine to a cosine. And so by the time you get to the second one, you've got that integral back times some constant, depending on what everything else looks like. So yes, you should only have to do it twice. Okay, any other questions? Okay, then like I said, we'll spend one more day on this tomorrow, and then we'll move on to our next technique for Thursday. Okay, and I'll be working on creating the homework. Okay, bye guys. Remember, if you need extra help, you should find me. Okay.